Welcome to the video on factor analysis. This video is again designed for beginners of SPSS who have the relevant knowledge on factor analysis. It will again help in solving an exercise that is given later. We will be performing an exploratory and a confirmatory factor analysis. We will evaluate results generated. We will interpret results together. And I will show you how to use factor scores in a regression model afterwards. There's an article that forms the theoretical basis of this example. And this is the article by Yu et al. From 2011, which is concerned about measuring Hofstede's 5 dimensions of cultural values at the individual level. I would recommend that you read the article beforehand. I have now opened the dataset that we will be using for our example. The dataset is called Culture Spain. When you click on Variable View, you get an overview of the variables that are included in the dataset. Basically, it is data that we collected among about 180 Spanish students that were asked to indicate their agreement to statements that were developed to measure cultural values on the individual level. So the idea of this dataset is that we measure different cultural values among individuals that are able to measure the different cultural dimensions that were defined by Hofstede. So for example, these first items here, P01 to P05, were designed to measure the power distance among individuals. And that is basically done by formulating a statement. People in higher positions should make most decisions without consulting people in lower positions, to which then the agreement was asked. And then agreement is asked on a 5-point scale from strongly disagree to strongly agree. And that is done with 20 different items. You can see them here. And the idea of these items is that they measure the cultural values. So power distance, uncertainty avoidance, collectivism, and masculinity. In addition to the cultural values, the students were also asked about their entrepreneurial intentions. And that is done using 3 different items. To what extent have you considered starting your own business? Have you prepared to start your own business? And how likely is it that you start your own business in the next 5 years? Finally, the dataset also includes some information about descriptives, namely about the age, the gender, and the number of semesters that students are studying. The idea of our factor analysis is now that we try to identify underlying dimensions under these items or statements. The first thing that we will be doing is an exploratory factor analysis. That is, we would like to identify, are there any dimensions behind the items in our data set? And we would start with our cultural values. So we would start using the first 20 items given over here. It is not 100% an exploratory factor analysis, as we know that the authors already had an idea of underlying dimensions. They already had the idea that there are 4 underlying dimensions under these different items, namely power distance, uncertainty avoidance, collectivism, and masculinity. But it could also be that you have a data set where you just have 20 different items and you need to fully exploratory find out, are there any dimensions underlying these different variables? Let us take this perspective of an exploratory factor analysis and then later on see if we can confirm the initial assumptions by the authors that there are 4 different dimensions underlying the cultural values. Let us now start to perform a factor analysis. For a factor analysis, the variables must be correlated. The idea of the factor analysis is that we bundle correlated variables together to factors. And for that purpose, of course, we need to see some good and high correlations between our variables. And that is the first thing that we will do when we perform a factor analysis. We check or we compute and test the correlation metrics. The first thing that we will be doing is we click on Analyze, Dimension Reduction, and Factor. And then a menu opens up. And you can see that I have already done a factor analysis before. So per default, there are already the variables in the box. I will just reset that to show you how it works. You should see this box here, and then you select all the relevant variables that you would like to perform the factor analysis for. And in our example, we will select all of our cultural values. That is, all items that are supposed to measure the cultural values on individual level. You will select all of these and bring them into the box on the right side. The next thing is that we click on Descriptives. And after doing so, another box will open up where we have to check some of the boxes. We will be interested in checking the correlation matrix. So we would like to see the correlation coefficients and their significance levels. We would also like to have some tests performed that will help us in identifying whether our variables are appropriate for performing a factor analysis. And that is, we will be interested in performing the KMO and Bartlett's tests. And we will also be interested in having the measure of sampling adequacy that is provided in the anti-image matrix. So basically, we check coefficients, significance levels, KMO and Bartlett's test, and anti-image, and continue. Before going through the next options that we have, I will first click on OK and show you what is the outcome of these analyses. You will see that SPSS is again communicating with you via the output document. And the first thing that is provided in the output document is the correlation matrix. In the correlation matrix, we would check if there are variables that are highly correlated and therewith adequate for performing a factor analysis. The first thing that you can see here are the correlation coefficients. So for example, the value here of 0.560 is the correlation coefficient between the statement people in higher positions should make most decisions without consulting people in lower positions and the statement that these people in higher positions should not ask the opinions of people in lower positions too frequently. You can see you have the diagonal elements over here, and basically here you have the same values as here. So you can decide on which part of the correlation matrix you want to concentrate. And the idea here is that you should be able to identify some relevant correlations between the variables. In a factor analysis, when we talk about relevant correlation, we often use a rule of thumb of 0.3. So that would be good for a factor analysis. You can moreover check the significance of these correlation coefficients. So we again have here the result of a hypothesis test where we are interested in rejecting the hypothesis that the correlation between the two variables is 0. And what is provided over here is again the p-value. And we would need to check, is this value below our desired level of alpha of 5%? If so, we reject the hypothesis that there is a 0 correlation between the two. So we are interested in having values here which are below our desired level of alpha, for example, below 5%. And we can immediately see that there are a couple of correlation coefficients, obviously, which are significantly different from 0. We see that even with our 20 variables, it's quite a huge task to go through all of these different correlation coefficients and their significance levels. We can scroll to the right side. I mean, at first sight, we can see, okay, there are some correlations that are significant. That's a good first sign. But it's rather hard to go through all of these values, especially if you have an example where you might have even more than 20 variables. For this purpose, we can use further test procedures that make our life a little bit easier. And I will just scroll down to make that visible. The first two tests that we are interested in are the KMO and Bartlett's test. The KMO, or Kaiser-Meyer-Olkin measure of sampling adequacy, tests the whole correlation matrix for its adequacy for factor analysis. It is a measure where we are interested in having a value which is above 0.5. So 0.5 is our threshold value for the adequacy for factor analysis. In our situation, we have a value of 0.746, which is higher than 0.5. So we can conclude, yes, the data is appropriate for performing a factor analysis. There are even data tables that provide us an idea how good is the data. And we can there see with a value of 0.746, we know that our data is quite good for a factor analysis. The next test is the Bartlett's test of sphericity. And the Bartlett test simply is, again, a hypothesis test. Basically, the 0 hypothesis here is that the variables of the population, or all the variables of the populations, are uncorrelated. And again, we would be interested in rejecting this hypothesis. We would reject the hypothesis as soon as our p-value here is below our desired level of alpha. So for example, below 5%, 1%, 10%, depending on your researcher's level of alpha specified. In our situation, we have a p-value which is clearly below any of these thresholds, so we can reject the hypothesis that the variables of the populations are uncorrelated, and we say yes, the data is appropriate for factor analysis. In that situation, we would be super fine with continuing. Might also be that the values are not as good or not good enough for a factor analysis. Then a super good next step, and also a good step to perform anyways, would be to look at the individual measure of sampling adequacy on the level of the variables. And this value is provided in the anti-image matrix that is given over here. And we would be interested in the anti-image correlation. And on the diagonal elements of this matrix, we can see the measure of sampling adequacy on the level of individual variables. This matrix builds basically on partial correlations and tests whether each of the variables is adequate or appropriate to be used in a factor analysis. It tests whether the variable is highly enough correlated with any other variable in the dataset to make it an appropriate part of our factor analysis. And that is the case as soon as we have an MSA value which is above 0.5. So we need to check whether these diagonal elements, here all indicated with a small a, are all higher than 0.5. In our example, that is the case for all the variables that are included. We can quickly check if that's really true. Yes, and it is. It might be that another example that you are performing, that this is not the case. So for example, you might have one variable, let us take an example, CO5, where you have the measure of sampling adequacy of 0.763 in our example, but you might have here a value of 0.3 or something like that. Then that would give you an indication that you should exclude the variables from the factor analysis. So in that situation, you would exclude the variables which have a value below 0.5 and then recontinue with the factor analysis without these variables. In our example, all the variables can be used, and we are super fine with continuing with our factor analysis. We would now like to continue with the factor analysis and finally extract factors. For this purpose, I will open up the factor analysis menu. So I will click on Analyze, Dimension Reduction, Factor, and then we will click on this next option here, which is called Extraction. In Extraction, you can see that we have here on top of that, we can specify the method. And in our case, the default is principal components. Principal component analysis is the most common method when performing a factor analysis, and I would always recommend that you use it as a default. The idea of a principal component analysis is that it tries to answer the question, how can variables loading on a factor be summarized? You will see here that there are a lot of different methods that you can use for a factor analysis. So factor analysis is not one method, but there are various methods that you can use for performing it. Again, we will continue with principal components. So we can specify the method, and we can also specify how SPSS shall extract the factors. And basically in this menu, there are two different items. There is first the version that we can do that based on eigenvalues and eigenvalues greater than 1. The second option is called fixed number of factors and factors to extract. So let us start with the second option, just to make that clear. If we click on that, we can ask SPSS to extract a fixed number of factors. This is always then useful as soon as we know that there is a certain number of factors that we would expect in the data. We could argue that for our example, we would expect that there will be 4 factors that SPSS shall extract, because the authors already had in mind that they have 4 different dimensions of culture that they would like to measure by their individual statements. So we could go on and specify and say we would like to extract 4 factors. This is not so much the standard case. The standard case is really using the option here to do that based on eigenvalues. And that would be the full exploratory approach, namely asking SPSS to do an extraction of factors building on these criterion of eigenvalues. An eigenvalue is the amount of variance that is associated with a factor. And the idea that this shall be higher than 1 is that standardized variable has a variance of 1. We know that already. That would mean that a factor that has an eigenvalue of 1 is not better than a single variable. So we would only be interested in extracting factors as soon as they have more explained variance as an individual variable could do. We would click on Continue. And I will first show you what is the outcome before we continue with the next menu items. So we click on OK, and again SPSS is reproducing the whole output, and I need to scroll down to go to the next output of interest for us. And this next output, which is of interest for us, is called Total Variance Explained. In the Total Variance Explained, we can see that we have here the eigenvalues, and we have here our factors, which are called here in SPSS components. What you can see is, as soon as we extract as many factors or components as we have variables, namely 20, we are able to reproduce 100% of the information of our variables. This is not so much a surprise, saying that when we extract 20 factors for 20 variables, we can reproduce 100% of the original information of the variables. We can also see that we have here the eigenvalues provided, so the total variance that is explained by each of the factors. And the idea was that we extract a factor as soon as it has an eigenvalue which is higher than 1. So we can see here that we have a cut over here after 4 different components or 4 factors which have an eigenvalue which is higher than 1, and we have here 15 or 16 components which have an eigenvalue below 1. And that means that SPSS is extracting 4 factors in our situation, with a cut made over here. The 4 factors that are extracted explain in total 47.92% of the variance of our original variables. That basically means that we have reduced the amount of variables that we will use in further analysis to 4 factors. And these 4 factors are able to reproduce almost 50% of the information that was beforehand bundled in 20 different variables in our dataset. 47.92 is not a super good value. Often what you see as a rule of thumb is that this value should be higher than 60%, something like that, but it's also not that bad. The next information that we would be super interested in is learning which variables are now bundled in these 4 different factors. So which variables actually belong to which of these factors. We could do so by looking at the further outputs, but I would like to recommend that we first ask SPSS to perform some further analysis for us. For that purpose, we will again click on Analyze, Dimension Reduction, Factor, we know that by now. And we have here the next option, which is called Rotation. And if we click on Rotation, we can see that we have different options to rotate the factors. Basically, it is not always necessary to do a rotation of factors. The rotation helps in later interpreting the factors because it often helps to have a clearer assignment of variables to a factor. The most common method for rotation is Varimax. It is an orthogonal rotation of factors, which has later the advantage that the factors are independent from each other or remain independent from each other. So I would always recommend, especially when you are a beginner, to use a Varimax rotation. So we will ask SPSS to do a Varimax rotation of factors, and we will continue. Another thing that I would recommend before we ask SPSS to reproduce the output is that we click on Options. And if we click on Options, we can, of course, also again talk about the missing values. We just leave it here with a default. But we can also ask SPSS to sort the different coefficients or loadings later by their size. And that's super convenient, but we'll see later, to ease the interpretation of the question which variable belongs to which factor. So we will ask SPSS to sort this by size and continue. We will now click on OK. Again, the whole bunch of outputs is reproduced, and we went through most of it already. And we are now interested in our rotated component matrix. So basically what you have over here is a component matrix and a rotated component matrix. The component matrix is the output of the factor analysis before the rotation was performed, and the rotated component matrix is the matrix after the rotation is performed. Let us maybe start with the rotated component matrix. What is given in that matrix are the loadings of individual variables on a factor. This is nothing else than the correlation of each of the variables with a factor score. And what you can do in the rotated component matrix, you can try to identify which variables are now loading highest on which of the components or factors. So for example, the first variable given over here, which is called CO3, group welfare is more important than individual rewards. This is correlated with a correlation coefficient of 0.759 with the first factor. It has a loading of 0.759 with factor 1. And we see that it's only if at all, correlated with the other factors. So there are correlation coefficients or loadings to the other factors which are around 0. That already means that first variable is belonging to factor 1. And that is the way that we will check for all of the different variables on which factor do they load. And we can see that we have the situation that the first 5 variables that are listed over here are loading on the first factor. And also this one, should not forget about this. 0.520 is also highest correlated or shows the highest correlation with the first factor. So these 6 first variables are most highly correlated with factor 1 and therewith form factor 1. The good news is that these 6 variables seem to all belong to what the authors had in mind, namely to collectivism, because we see that these are all the statements that belong to the idea of collectivism. Let us see if the analysis is as positive for the next variables. We see that the next high correlations are then here for factor 2, given for these items. And we can see that these all seem to belong together and belong to factor 2 because they have the highest loading with factor 2. And again, it seems to be a positive situation in terms of our theoretical idea. These seem to all belong to power distance as envisaged by the authors. I will further scroll down. And then we see that the next highest loadings are beginning here with 0.7339. And we can see that we have here high loadings with this third factor for these variables. And if we look to the left side, we can see super. These are all the variables that were designed to measure uncertainty avoidance. So all the uncertainty avoidance variables are bundled together in factor 3. And finally, we have here a set of items or variables that belong together to factor 4. And these are all the items that measure or were supposed to measure masculinity in a society. If you would have performed a factor analysis on a different set of variables where you did not have specific dimensions in mind, the next step would be to interpret the factors that you have generated. What would you do? You would look at which variables are bundled to which factor. And would you be able to find a name or an idea or a construct that might underlie these different items? So what would you do? You would read through the different items that are bundled for each of the factors and try to find an umbrella term that best describes the dimension that you have identified in the dataset. In our situation, it is super easy because we already know that these items were supposed to measure masculinity. So we already know that masculinity might be a good umbrella term for this factor 4 here, measuring masculinity on the individual level of respondents. Let us maybe have a quick view on the component matrix to show you the difference between the two. And I think in this example, it is super obvious that rotation will help, because you can see here when you look at the component matrix that the first variable has a high correlation with the first factor, the second also. And then we have a situation where there are rather high loadings with different factors. And that is true for many of these variables. So the assignment of variables to factors is not at all clear. We do not really know which variable does belong to which of the factors because we have the situation that the loadings are rather equally high for different factors. And in this example here, it is definitely the case that rotation is very helpful in order to interpret the factors and the assignment of individual variables to the factors. But that's not always the case. Sometimes it's also already very clear from an unrotated component matrix to which factor a variable belongs. But I think it's quite a useful tool to use a rotation to go on with an interpretation of variables. Now that we have an idea which variables belong to which factor, we are super interested in using these factor scores or these factors for maybe further analysis. Because the factors now enable us to reduce the whole data set with 20 variables to a situation where we would only have 4 factors. And we know already from our examples and regression analysis that if we have a situation, for example, where there's multicollinearity between the different variables, it might be useful to bundle all the variables to factors that are multicollinear to keep most of the information that is in different variables without having the problem in the regression analysis later that we have variables that are highly correlated with each other. So what we are interested in is we are using the factors for further analysis. For that purpose, we can click on Analyze, Dimension Reduction, Factor, and we will ask SPSS to save factor scores. So we click on Scores, and then this box opens and we can say, yes, we want to save the factors as new variables. If we click this checkbox, SPSS is asking us which method shall it use to create the factor scores. And in our example, we use the super common method of regression to do so. So basically, the factors are created as a linear combination of the different variables with the factor scores or with the loadings with each of the factors. So we will use the regression analysis to save factor scores. I will click on Continue and on OK. Then SPSS is again creating the whole output. And the most interesting information is now provided in the dataset. I will click back to the dataset. And you can see in the variable view that SPSS has produced 4 new variables called FAC1, 2, 3, and 4. And we see that this is a factor score produced by means of a regression analysis. So basically, SPSS is calculating a new score for each individual in the dataset for our 4 factors. The first thing that we might want to do is we should give these factors a name. For that purpose, we would need to remember which was behind the different factors. And I have already almost forgotten which factor was which, so I need to click back to our factor analysis output and to our rotated component matrix to ensure that we have the right factor names. So the first factor was our collectivism factor. The second one was power distance. The third one was uncertainty avoidance. And the fourth one was masculinity. And we can use that to rename the variables here. So we had the first one was collectivism. The second one was power distance. The third one was uncertainty avoidance. And the fourth one was masculinity. Hopefully I remember that correctly. And we can also use the same things here and specify it in the label to make sure that we know what it is. You could be better than I do here and say factor score measuring collectivism or something like that, as you prefer. If we click now on the data view and we scroll to the right side, we will see the variables or the scores for each of the respondents for the 4 new variables on the dataset. So these are the scores of the individual respondents on the 4 factor values that we have. Let us see what the different values represent. We have, for example, for our respondent number 1, a score which is minus 0.82 and so forth. That means that is a value which is below 0 and therewith a value which is lower than average. So respondent number 1 has a below average collectivism value. If we have a value which is higher than 0, we know that the respondent is above average. So, for example, we can see that respondent number 4 has an above average value for collectivism. So respondent number 4 would be a person that has a collectivistic mindset, whereas person number 1 would rather have an individualistic mindset. So we have now factor scores that we can immediately interpret in terms of their values. And the good thing is also that we could use these factor scores for any further analysis. So we might be interested in learning what is the effect or the outcome of collectivism, power distance, uncertainty avoidance, and so forth on any other variables that we have collected in a survey. And we can use these factor scores now for the further analysis. We could, for example, be interested in learning how do these cultural values determine the entrepreneurial intentions of people. For that purpose, we would perform a regression analysis where collectivism, power distance, uncertainty avoidance, and masculinity are the independent variables, and entrepreneurial intention would need to be measured as the dependent variable. We remember that we had in our variable view 3 different items that were supposed to measure entrepreneurial intentions. So what could we do to perform a regression analysis for entrepreneurial intentions? Yes, we could create a factor that measures entrepreneurial intention. And let us do that factor score for entrepreneurial intention following a confirmatory approach. So the idea is that we know from many studies that these 3 different items are measuring entrepreneurial intention. Yeah? We already know that almost safely that this is a good measurement for entrepreneurial intention. So we would not expect to do an exploratory factor analysis, but we would rather try to confirm that these 3 measures are also in our data set measuring entrepreneurial intention. What will we be doing? We would analyze and perform a factor analysis by clicking on dimension reduction factor. And we would this time not use the cultural values, but we would use our entrepreneurial intention variables. Where are they? Here. ER1 to ER3. Bring them over to the box. We might perform all the different descriptives and extraction and rotation and so forth. But here in this case, we would be interested in SPSS creating one factor for us. So I click on extraction, keep it with principal components, and say I would be interested in having a fixed number of factors, namely one factor out of these 3 variables. And I will click on continue and click on OK. Then SPSS is reproducing again the whole output. And we might, in this scenario, also check how good was our data. And a quick check here of our KMO criterion above 0.5. Significant Bartlett's test, super good. Anti-image diagonal elements, the MSA criterion for the individual variables, all above 0.5, super good. Total variance explained by one factor extracted is 70%, super good value. So 70% of entrepreneurial intentions incorporated in 3 variables are now explained by just using one factor. And we can see here the component matrix showing the different loadings of these individual items on the factor. There is no rotation because we only have one factor, so there's nothing that we can rotate. And we can see that we have rather high loadings of the individual variables with a factor, which are all above 0.7, which is a good critical threshold value to indicate is it a good factor or is it not a good factor, or is there enough factor loading or loading of individual variables on that factor. So in our scenario, that's kind of a super good situation. We have all the variables, and as we have not changed the save option, SPSS has already created a new factor score in our dataset that is now measuring entrepreneurial intention. And I will just give the variable the respective name and say entrepreneurial intention and save the dataset. Good. Now we have a factor score for entrepreneurial intention and factor scores for our 4 different cultural values, and we could continue with a regression analysis. Before we start with our regression analysis, I would like to introduce one more test, namely a test on reliability. So basically, you can finally evaluate the quality of the factor and therewith of your new scale here for entrepreneurial intention by checking its statistical reliability. How reliable is the measure or the scale measuring entrepreneurial intentions? You can check the reliability of the scale constructed by referring to Cronbach's alpha. Cronbach's alpha is a coefficient which analyzes the correlations between subsets of the scale items, so between the subsets of our three variables. It varies from 0 to 1, and a value of 0.7 is considered as acceptable. So a value of 0.7 indicates reliability of the scale. How can we calculate the reliability of our scale? We will, for that purpose, click on Analyze. And there you can see that there's an option which is called Scale Reliability Analysis. Clicking on that, a menu opens up where you can select the different items for which you would like to perform the test. And I will choose the three different variables that we have been using to construct our entrepreneurial intention scale and move them into the box on the right side. You see here that we have a model which is called alpha, so that is Cronbach's alpha. You could provide a label to the scale. You could call it entrepreneurial intention, but that's actually not really necessary. That's only good for you to keep an overview later on the output. If we click on OK, you will see that SPSS is producing the reliability statistics, and it's producing it, the Cronbach's alpha, for the scale entrepreneurial intention. And we can see that we have a value of 0.790, so a value above 0.7, indicating that our scale is a reliable measure of entrepreneurial intention. Super good. Now we have an input on our scale on entrepreneurial intention, which seems to be reliable according to our tests. And we could now perform a regression analysis, for example, with the data that we have. And you know all the menu options for a regression analysis. I will just quickly start one just to show you that you can use the factor scores for the regression. So you will open up your regression menu, and in the box that you have, you will choose your new factor score or scale entrepreneurial intention as a dependent variable and our four cultural value factors as the independent variable. And you can ask SPSS to perform all your well-known different test statistics and so forth and perform a regression analysis. In my example, it obviously is the case that I have a very low R-square of 4%, so a rather poor model in terms of explanatory power. So our cultural values are not super good in explaining the entrepreneurial intentions of students. And we can go on and check, are there any significant coefficients that might be relevant in indicating if someone has an entrepreneurial intention? And in that example, just to quickly do that, we can see that uncertainty avoidance has a negative standardized coefficient, which seems to be significant, at least on a 10% level. That means individuals with a higher uncertainty avoidance will have a lower entrepreneurial intention. That somehow makes sense. So people that have tried to avoid uncertain situation are not engaging in starting their own business. Then we would have another significant coefficient for power distance, which is positive. That means the higher the power distance of a person, the higher its intention to start their own business. Now, we could try to find some explanations for that as well. But that's the basic procedure to now use factor scores for regression. And again, you can combine the factor scores, of course, with any other variables in your data set. So for example, you might want to add age, gender, or the number of semesters that might be relevant for entrepreneurial intention, and mix that with the factor scores. And then you would continue with all your different analysis in your new model. So now we have learned how to create factor scores with an exploratory approach. We have learned to create a scale using a more confirmatory approach of factor analysis. We are able to check the reliability of the scale, and we are able to use factor scores in further analysis, for example, in regression analysis. Now you have the toolset that you need for performing an exercise. We have another dataset which is called Culture Germany. And what a surprise, it covers all the cultural values that have been collected among German students. You can do a factor analysis on the German cultural values with all the different analyses that are part of a factor analysis. You can save the factor scores. You can perform a more confirmatory factor analysis for entrepreneurial intentions for the German dataset, interpret the quality of the factor, including reliability. And you might then continue in performing a regression analysis for the German sample, in which entrepreneurial intentions are again the dependent variable, or is the dependent variable, and the cultural values are your independent variables. And then you will give an interpretation of the final regression model and check if the regression assumptions are met. If you still have time and motivation, you could start performing a factor analysis on the institutional environment data that you have collected, because that will be absolutely the same procedure that you can use on this data set. So that means you would perform a factor analysis on the institutional environment data to create factors that you will then use to perform a regression analysis on the dependent variable that you have chosen, for example, on your mergers and acquisitions, on your greenfield investment, or on your FDI. Have fun in doing the exercises. Again, my recommendation is that you might want to have a look into the book by Marco Saarstedt and his colleague, which is providing a wonderful chapter on factor analysis, giving you all the different background information on the procedure itself, plus giving you some examples on how to do it in SPSS.